Hi, welcome back. In this video, we're going to compute the determinant of this matrix using a cofactor expansion. Now remember, you can only find the determinant of an n by n matrix, a square matrix, and if you do a cofactor expansion along one of the rows or one of the columns, it's going to be a finite sum with exactly n terms in it. So we've got a 4 by 4 matrix, so our sum is going to have just 4 terms in it. But I just want to remind you in general what the cofactor expansion would look like. So if we choose a row, say we choose row I, then the determinant of the matrix is going to be the first entry in that row, I1, times either positive or negative 1. It's going to be negative 1 raised to a power, I plus 1, which is either even or odd, right? At times the I1 minor. Remember, the I1 minor is just a determinant of a submatrix. The submatrix you get when you delete the ith row and the first column of the big matrix. Then the second term is AI2, the second entry in the ith row, times either positive or negative 1, so it's negative 1 raised to the I plus 2, times the I2 minor. That's the determinant of the submatrix that you would get by deleting the ith row and the second column from the big matrix. And then you keep going until you get to the last entry in that row and multiply by either positive or negative 1, and multiply that by the IN minor. That's the determinant of the submatrix you get by deleting the ith row and the nth column. So that's what a row expansion is. You can do the same thing along a column. So say you decided to choose the jth column of your matrix and you want to expand along that. You take the first entry in that column, A1j, multiply by negative 1 raised to the 1 plus j, multiply that all by the minor M1j, which is the determinant of the submatrix you get by deleting the first row and the jth column. And you keep doing that. The second entry is A2j times negative 1 raised to the 2 plus j times the M2j minor all the way up to the very last entry times negative 1 to the n plus j times the mnj minor. So we can choose any column or any row. And we always want to sort of choose it strategically to sort of simplify our work. So in this example, I'm looking at my matrix, trying to decide which row or which column I want to expand along, and I see that the second row has a couple of zeros in it. So that's always a good tip. Look for the row or the column that has as many zeros as possible. So this means that my sum is really only going to have 2 terms in it, because 2 of the terms are going to have a factor of 0. It'll simplify our work. So let's expand along row 2. All right. So the row 2 expansion for the determinant of that matrix, we know the terms are going to alternate in sign, positive, negative, or negative, positive. So let's just figure out whether the first term is going to have a negative 1 or a positive 1 in front of it, and then we can alternate after that. So the first term is going to be the A21 term. That 3, the first entry in the second row, is the A21 term. So that means it's going to be 3 times negative 1 raised to the 2 plus 1. So it's going to be a negative 3 in the first term. And then after that, we're going to alternate in sign. it's going to be the Aij entry times either a negative or positive 1. All right, so let's start writing down the determinant. The first term is negative 3 times a smaller determinant. And so the smaller determinant is going to be the determinant of the 3 by 3 matrix we get by deleting the column and the row that A21 entry is in. So we're deleting the second row and the first column. And so that means we're taking the determinant of this 3 by 3. And then the second term in our sum is going to have a minus 1, or sorry, it's going to have a plus 1 because we're alternating in sign. The first term was already had a negative 1 in front of it, so then we're going to have a plus, but then the second entry in that row is a 0, so we don't really care what the determinant is that we're multiplying it by, because we know we're multiplying by 0, so it doesn't matter. But then the next term is going to be negative 7, because 7 is the next entry in row 2, times a determinant of a smaller matrix. And how do we get that smaller matrix? Well, we delete the row and the column that 7 is in. Like that. There we go. And so the submatrix we're taking the determinant of is 2, 6, 12, 4, 1, 2, 1, 5, 10. And then the last term is going to be plus, but it's going to be 0 times some determinant of some submatrix. We don't care what it is because we're multiplying it by 0. All right, so let's start computing these minors. So the first one, so we've got a negative 3 times a determinant of a 3 by 3 matrix. So looking at the 3 by 3 matrix, I don't see any zeros. So basically any row or any column could be used. So I'm just going to use the second row. So since I'm starting with the second row first column, the entry there is 1, but 2 plus 1 is odd, so it's going to be multiplied by a negative 1. So the first term in our cofactor expansion of this submatrix determinant is going to be negative. So it's going to be negative 1 times, and then we're going to do the determinant of the 2 by 2 matrix that we get when we delete the second row first column. Okay, so the determinant, remember, of a 2 by 2 is AD minus BC, so it's 110, 11 times 10, 110 minus 12 times 2. So 110 minus 24 is 86. All right, and then the next term in this expansion is the next entry is negative 1, but we're going to be multiplying it by a positive 1 because we're alternating in sign. We started out negative, so now we're positive. So it's plus a negative 1 times a determinant of a submatrix. The submatrix we get by deleting the second row and the second column of the 3 by 3. So that's going to be the determinant of the 2 by 2, 6, 12, 5, 10. So it's going to be 6 times 10 minus 5 by 5 times 12, which is 0, which is nice. And then the last term is going to be minus 2 times another determinant, and that determinant is going to be the determinant of the 2 by 2 that we get by removing the second row and the third column of our 3 by 3. So that determinant is 6 times 2 minus 5 times 11. So 12 minus 55 is negative 43. All right. So that's the first term in our cofactor expansion. And then we have a 0 minus 7 times another determinant of another 3 by 3. So I'm going to choose the first column to expand. So the first term in the sum that I'm going to write down is has a positive 2 because I'm starting with the A11 term. And 1 plus 1 is even, so it's going to be positive 2 times the determinant of the submatrix we get when we delete that first row and that second column. So the determinant is going to be 1 times 10 minus 5 times 2, which is 0, and that's nice. All right, so the second term is going to be negative 4, because we're alternating in sign, times the determinant of the submatrix I get by removing that second row and that first column. So it's going to be 6 times 10 minus 5 times 12, which is another 0. This is handy, having lots of zeros. All right, and then the last term in that sum is going to be positive 1 times the determinant we get when we of the matrix we get when we remove that third row and that first column. So the determinant of that little submatrix is going to be 6 times 2 minus 12 times 1, which is another 0, and that worked out nicely. Doesn't always work out that nicely. So simplifying, cleaning things up a little bit, we end up with negative 3 times negative 86 plus 86, which is just 0. So our determinant turned out to be 0. All right, so we're going to learn more facts about determinants and determinants of special matrices in the next section, namely elementary matrices. All right, so that's an example of a cofactor expansion. I chose to do an expansion along a row. You could choose any row, any column. Choose strategically. If you see a lot of zeros in a particular row or particular column, that's the one you're going to do. All right, I will see you in the next video.